All right, well, it is 10:30 a.m. Pacific time, and I know we don't have all the time in the world for today's session, so I'd like to get us started. My name is Olga Kachuk. I'm a project manager with the Sustainable Packaging Coalition, and this session is the how, what, and why of bioplastics, just making sure we're all in the right place. And I'm very excited to have a conversation today about bioplastics and all the different kinds of bioplastics with Kelly Morosky from 7th Generation and Jason Laughlin from the University of Georgia. So with that, I'd like to just give you both a chance to introduce yourselves in a little bit more detail, briefly tell us about your work and how it intersects with bioplastics. So Kelly, if you wouldn't mind kicking us off.
Great, thanks. Hi, everyone. I'm a senior packaging engineer at 7th Generation. I've been with the company just over 5 years now. And at 7th Generation, I work on a diverse portfolio of packaging types for both home care and personal care products. So we have everything from rigid plastics to flexibles to cartons. And 7th Generation has a bold 2025 goal to eliminate the use of virgin petroleum plastics and fibers in all of our packaging components. So essentially, what this means is looking to design packaging with 100% post-consumer recycled plastics or fibers, and we also look to utilize bio-based plastics when needed.
Great. Jason, how about you?
Hey, good afternoon or good morning on the West Coast. My name is Jason Laughlin. I'm a distinguished research professor in chemistry engineering at the University of Georgia, and I'm the director of the New Materials Institute, which is focused on teaching, bringing end of life in the design stages when we train the next generation of scientists and engineers. I'm a polymer chemist by training, and a lot of the work that we do in the New Materials Institute is focused and centered around displacing persistent plastics in the environment with materials that have a different, that can be used in a more circular materials management strategy.
Fantastic. Thanks for the introduction, both of you. And one thing that I want to do before we kick things off is to just do a very, very short level setting on the topic of bioplastics. So I will share a that is helpful for thinking about bioplastics. Let me know if it looks like my screen is going through. So this is, and let me know if it's, there we go, I think it is. So really, the reason why bioplastics can be a little bit complicated sometimes is because there's a whole family of different polymers and materials that we are talking about when we talk about bioplastics. And different people are sometimes referring to different parts of the quadrant when they talk about bioplastics. And so I just wanted to kind of do a little bit of a background on the diversity of materials. So what you see is that we have some bioplastics that are not biodegradable, and then we have other bioplastics that are biodegradable. And we also have bioplastics that are bio-based, which means they come from, biomass or plants or essentially, living material. And then we have, we can also have bioplastics that are fossil-based. And I think that can often confuse folks, the fact that there are, bioplastics that are even biodegradable that can be actually that come from fossil resources. So this is helpful for, thinking about the whole family and for kind of zeroing in on the different types of materials that we're actually referring to. Sometimes one of the we sort of jumped directly to talking about compostable bioplastics. They are, of course, just a subset of the different kinds of bioplastics out there. And so with that as a sort of jumping off point for us, I wanted to ask Kelly, if you could share more about the kinds of bioplastics that you're using at 7th Generation, where they sit in this quadrant, and what their end of life or recovery option is. Are you looking to have these materials be recyclable? Are you looking to have them be compostable? How do you see, the different kind of options for bioplastics fitting in on this quadrant for the materials you're using?
Yeah, so looking at the quadrant, we focus on materials that are in the top left-hand corner of that quadrant. And what we call them is a drop-in bioplastic. So a drop-in bioplastic is something that uses plant-based feedstocks to create a polymer that is the same molecular base as a fossil fuel-based plastic. And this means that that drop-in bioplastic is fully recyclable and does not contaminate the recycling stream for that specific plastic type that you're focusing on. So at 7th Generation, we currently use the Braskem I'm Green polyethylene in some of our larger liquid format bottles. So this is a plant-based high-density polyethylene that's derived from sugarcane. For these larger bottles, we were having issues reaching 100% post-consumer recycled plastic. So we use the Braskem Green PE as a supplement to improve our PCR bottle performance and as well as to help with processing. So a couple examples of this is that our 100 ounce and our 150 ounce laundry bottles are 80% PCR HDPE. They're then mixed with 17% Braskem, which is the BioPE Braskem, and then a final 3% white colorant. So this inclusion of the Braskem was able to increase our stress crack resistance in the bottle and also improve processing while still allowing us to meet our zero virgin petroleum goal for our bottle types.
Fantastic. That's really helpful, I think, for folks to hear kind of how bioplastics fit into, packaging portfolio or into specific design decisions when you have some PCR and then you're trying to, source the rest from renewable or sustainable resources. So with that, I want to jump to talking about compostable bioplastics, which is, I think, one of the things that people immediately go to when they think about bioplastics. You were talking about the drop-in bioplastics, Kelly, and I'm curious to hear from both of you, when might compostable bioplastics make sense? So Jason, if you wouldn't mind sharing your thoughts on that.
Sure, absolutely. Well, compostable bioplastics, I think, make the most sense in areas that recycling is either impossible or economically very difficult. So for example, if you think about things like food packaging, right? Films and food packaging, classic potato chip bags, or meat packaging, or whatever it might be, items that are heavily contaminated with food waste or organic matter and have to be that require serious cleaning before being recycled. Also, materials, I believe that compostable bioplastics make sense in areas of single-use items and packaging, particularly if that packaging is lightweight film or foams or materials that are really difficult to collect in large enough volumes or costly to transport, to recycling facilities to accumulate enough volume to make the economics of the recycling process work.
Kelly, any thoughts on compostable bioplastics and whether they, make sense for 7th Generation, or if you've found that, considering the applications, you would prefer to stick with the drop-in bioplastics?
Yeah, I would have to echo a lot of what Jason said in focusing on those hard to recycle items, especially in the food industry. For 7th Generation, we prefer to actually stay away from compostable bioplastics since we are in that home care, making rigid plastic bottles. Consumers are used to recycling our bottle types. And really, if we were to give them a look-alike plastic bottle that's now compostable, I think they would be confused. And if anything, it would probably just lead to contamination within the recycling stream. So from a compostable bioplastic standpoint, we've chosen to step away from those and focus on recyclable bioplastics.
That makes sense. What about biocomposites? Let's talk about what those are, where they might be used, what their end-of-life options are. So Kelly, if you could start with that, your experience with biocomposites.
Yeah, so there are many different types of biocomposites, and it really depends on, what you're looking for. In the world of plastics, a biocomposite is a matrix of material composed of natural fibers mixed with a polymer, but the polymer that it is mixed with can change. So for example, you could have a fiber like bamboo or rice hulls blended with PLA. for a biodegradable biocomposite. But you can also blend these fibers with a plastic such as polypropylene, and you can use that to increase the properties of the polypropylene. But then that would ultimately have impacts on the recyclability stream of the polypropylene that the biocomposite is used in. So the end of life for biocomposites really depends on the makeup of it. For uses, I think it makes sense in more durable good, longer term applications. So we've seen biocomposites coming up in automotive and aerospace and construction because they can improve performance and also have those environmental benefits over traditional plastic. For consumer goods specifically, I think if we're mixing bioplastics with a traditional plastic such as polypropylene, I think they really only make sense for a durable good or a reusable package, and not so much for single use. As I mentioned, if you're using it and it will contaminate the recycling stream, but then on the other side of things, if you look for the biodegradable biocomposites, those could lend to things such as other single-use package types.
And maybe if I can just add,
go ahead.
Yeah, maybe if I can just add to what Kelly said, I think it's important, so biocomposites, simply, Kelly defined them perfectly. One of the things that we have to really keep in mind when you're talking about biocomposites is that those materials, particularly the natural material that's present, whether it be a reinforced fiber, bamboo is a good example, or cellulose or whatever it might be, those materials can be susceptible to, microbial degradation or water absorption or other abiotic or biodegradation processes. And you have to consider those types of things when you're thinking about sort of the structure and the functional stability of a material during its service life. So that would be basically one of the things that I would add. Biocomposites can be recycled. People have looked at mixtures of things like PLA with flax fiber, and those materials can be mechanically recycled. But the challenge is exactly what Kelly said. If you're competing or going to contaminate another recycling stream, then biocomposites can pose a big challenge, just like glass fiber reinforced polypropylene, poses a large challenge in a polypropylene recycling stream.
Mm-hmm. Jason, I want to ask you, especially given your role, what you think the opportunities are for sort of the newer bioplastics like PHA, like bioplastics made from algae, food byproducts like avocado skins. Where can we expect to see these products go? Are they, commercially feasible, scalable? Any thoughts on those kinds of new sort of bioplastics 2.0?
Oh, absolutely. So yeah, I guess we can start with PHA. So PHAs are a class of polymers, polyhydroxyalkanoates. They're a class of biopolymers that are made from natural organisms, whether it be bacteria, even some plants in certain cases. And PHAs are thermoplastic materials. So they have many of the same properties of some conventional plastics like polyethylene, low density polyethylene or polypropylene. And are showing lots of promise, or tremendous promise, in areas like packaging and paper coating and single-use items. And since those materials are made from natural organisms through fermentation, most likely, at their end of life, they can be consumed or taken up by natural organisms. And so, and another exciting thing, and one of the things about PHA particularly, is that those natural organisms exist in just about any environment on the planet of Earth, whether it be, compost, home or industrial, soil, freshwater, marine waters. There are organisms that consume PHAs have been identified in all of those. Now, the rate at which they degrade is the challenging thing, and that depends on the precise environment, just like other bioplastics that we're talking about. So the precise environment, the microbial load, all of those kind of things, and the dimension and thickness of the product. So, we like to equate PHAs to natural materials like paper. If you have a library book, you can store that on a shelf for hundreds of years. but that natural material, if exposed to moisture and organisms, can start to degrade just like a leaf. And also understanding and benchmarking that, you know, a leaf degrades a lot faster than a tree stump, right? So a lightweight package with high surface area will degrade a lot faster than, you know, a large void or a large material that's made of that. So there are, you know, there's essentially a race to market for PHAs today, and many companies, you know, around the globe are working for, towards that. As a plastic material, they have tremendous promise. I guess the real question for people like me is, do the economics of scale make sense with those materials? And only then will we see them start to displace certain materials in a lot of these applications I mentioned.
Mm-hmm. That makes sense. Kelly, when you think about how to market or explain the properties of your, you know, packaging and the fact that you do have drop-in bioplastics, how do you make sure that consumers understand what it is and that there isn't, you know, greenwashing around the communication of bioplastics, especially considering that many consumers might think of bioplastics equaling compostable bioplastics or at least bio-based, and you mentioned, you know, the drop-in options. How do you avoid greenwashing?
Yeah, I think it's important to have clear labeling if you do want to kind of market that fact on label, so that the consumer kind of understands exactly what it is. So for example, on Coke's plant bottle, they tell consumers that it is a redesigned plastic made from plants that is 100% recyclable. So I think the key call out here is that they are telling the consumers it's made from plants. They're not putting that word bio in front of it. That often can cause consumer confusion. And they are still calling out the recyclability of that plastic that they're using. For 7th Generation, on our labels, we denote that we're using PCR, and that so that 80% is PCR, and then 17% we call a sugarcane derived plastic. So then again, we are also telling the consumers that this is the plastic we're using. It is derived from sugarcane, so we go one step further, not just referring to it as plants. I think it's also important that if you're using a compostable bioplastic, that you're supporting that on pack with a compostability certification and claim, so that you're actually going through and doing the testing to help reduce that consumer confusion. Because I think one thing that we see all the time in the market is a standard PET cup next to a PLA compostable cup. And for a consumer, they really can't tell the difference. And having that compostability claim on pack can kind of give them the end of life instructions to then follow it correctly.
That's great. We just have I guess 2 minutes left. So I wanted to ask both of you what you feel like is the most important takeaway for brands that are starting to think about incorporating bioplastics into their packaging. What should folks know when they consider using any one of the sort of suite of bioplastics that are out there? Jason, how about you?
Sure, that's a great question, and that can answer in a lot of different ways. I think first and foremost, understanding the value and the goal or the impact of that materials choice to your company. So, you know, if your target is to reduce the use of fossil fuel resources, or have a smaller carbon footprint, or have a material that can return to the carbon cycle at end of life in the appropriate conditions, then I think bioplastics provide a lot of improved options over certain petroleum-based plastics in that particular space.
Yeah, and for me, I think with bioplastics, do your research. There's not kind of one size that fits all. I mean, we've only touched on it briefly today, but there are so many different types and distinctions of bioplastics that you really need to figure out what is fitting your brand or your product, and really your sustainability goals that you're trying to push.
Fantastic. Well, I want to thank you both for sharing your insights and your expertise. It's been a fantastic but short conversation, and I would encourage folks to continue to do their research and to dig into bioplastics. There's a lot to learn and a lot of nuances to the different kinds. So definitely echo what Kelly said about continuing to do your research. Thanks everyone for joining us, and we'll see each other in other sessions.
Thank you for your time.
Thanks everyone.